Our next presenter is Dr. Wenxu Li, who has expert knowledge of field measurement and data analysis. He has been involved in various rail and pipeline-related research and consulting projects. His particular contributions include wheel rail noise mechanisms involving sound and vibration field measurement and structural vibration and acoustic radiation model development. This has involved development of algorithms for prediction of noise emission from track components. He has also contributed to the development of degradation models and life cost analysis models for railway and pipeline assets. Welcome, Wenxu.
Thanks, Kevin.
Yeah, looks good. We can see your screen too.
My name is Wenxu Li. I'm from the University of Wollongong, Australia. So our presentation this time is on selection of track forms from an LCC perspective. Sorry. So the objective of our work is to answer the question, which track form should we use for a particular application? Is it a ballasted or ballastless? So in Australia, currently ballasted track is still the most preferred and the prevalent option for all applications and all traffic types. But the industry is interested in validity of a choice in the long term, and they have asked for comprehensive approach to enable them to effectively compare different track forms for specific applications, and we are commissioned to help them on this aspect. So it's noted application of slab track has been extended from the high-speed rail in the early design to various other applications. The notable one is in Australia, 650-meter slab track was built to carry heavy haul in 1906. So this gives us a kind of perspective that ballastless track may be also used more widely than is current situation. The existing approach to track selection is through this scoring system by listing all of the kinds of track forms and ask expert to give values to each of the metrics for the performance measure of these kinds of track forms. So the most preferred one are those with the highest score, say 39 in this particular case. But apparently, this method is very subjective. It demands high level of domain knowledge, and also we may confront with a dilemma, especially when two track forms have the same scores. So instead, we propose like a uniform framework to guide the selection of a track form. It uses both heuristic analysis and quantitative analysis. So the target is to make sure the selection is less reliant on expert, but more reliant on data. But in this talk, we only focus on part of the framework we developed. That's the LCC part, or life cycle cost. So we use life cycle cost as a measure because it's effective and also is consistent. That means it allows different track forms to be compared. In particular, we focus on the LCC models we developed. They are derived to adapt to different data situations and with different complexity. Then the proposed models are named as aggregated cost model, activity-based model, and also engineering model. So they are at the increasing complexity level, and the more complex the model is, as more data it will require. Then the first model and the second model are parametric based. The difference between them is the details of request on the cost. One is activity based, another one is aggregate cost based. And the last model is engineering one, is degradation modeling based, and it requires significant amount of data. All of the models are based on cost breakdown. So the three cost elements we consider are construction cost, maintenance cost, and disposal cost. For the first model, the assumptions we made for its implementation are construction time is insignificant, and maintenance cost is assumed to be a function of traffic load and headway, and disposal cost is only occurred at the end of service life of a track. So this is the equation we proposed. See the three cost elements are incorporated like this. Another factor we introduce is the adjustment factor. This is to account for similarity between the track where data are collected and the track where construction is going to occur. So the determination of the adjustment factor is through the traffic attributes we collected from both tracks. So we've already proposed a method to determine it in the paper. So the advantage of this method is it only requires limited data, but its application may be limited, is best suited for initial indication. The second model, the assumptions are similar to the first one, but the maintenance cost is at more detailed level. So we propose to include service and availability cost, inspection cost, repair cost, and also activity cost. So the corresponding to the equation is shown as this. Then this model requires more detailed data input, but it also allows targeted configuration. The third model is simulation-based. So we have to segment the track of interest and build the cost model for each of the segments based on degradation modeling, and also by including the the various maintenance policies for each of the components. Apparently, this model is very comprehensive, but it also demands specific engineering data. Because of the high volume of these requirements, so we are not in a position at this stage to implement this model fully. So in order to demonstrate the implementations of the model, we acquired data from the literature and also from the real operators. So this is the result for the implementation of the first model. Left figure is a ratio of LCC of a ballasted track and the slab track. The right figure is the sensitivity analysis result. As we can see from the last figure, this dot represents the time when the LCC of slab track and that of ballasted track equal to each other. This occurs at around 10 years after construction of the track. Since then, the LCC of ballasted track exceeds that of slab track. The jump in the curve is because of the renewal of the ballasted track, because here we assume the design level ballasted track is 20 years. And for the sensitivity analysis, we can see the various factors used in the LCC calculation, such as discount rates, construction cost, and maintenance cost of slab track can significantly affect the time when slab track is considered more cost-effective than ballasted track. And this is a result from the trial test of the second model. It gives us a similar result to the trial of the first one, But not shown here is this model also allows people to look at the effects of, say, the activity frequency change and cost change, etc., which is not enabled in the first model. So the conclusion of this work are 3 LCC models are developed, 2 parametric, 1 engineering to show different data situations and to allow different decision-making requirement. The usefulness of the 2 parametric model has been demonstrated. At the same time, we recognize the importance of establishing a comprehensive database that allow that can improve the track form selection, eventually leading to optimal life cycle cost for specific applications. From our findings, we recommend the industry work collaboratively to establish such international database by collecting data from various applications and on the different application context. Especially these ballasted and track applications on unconventional areas, such as heavy haul or mixed traffic, can be valuable because it can guide the huge and track form selection project. And then the last one is we recognize it's also important to include supporting structure in the track LCC analysis because track form can significantly impact the design and also construction of the supporting structure. So in terms of data required to implement the models, they include tracker condition data, tracker attribute data, and operating and maintenance data. Currently, we are still seeking cooperation with various international rail operator and managers to secure this data. Thanks for your attention.
Perfect. Thank you, Wenxi. We have a couple minutes here if anyone wants to ask a question. We have one from Richard Lany. I think you can unmute yourself, Richard, if you like.
Yeah. Did you consider the rail fastening systems in your analysis as well? I saw rail, I saw sleepers, I saw ballast. I was wondering about the rail fastening systems.
Because we developed 3 different models. So for the first model and the second model, we only look at the activity-based. Let's see for the second one, that's activity-based. Any maintenance activities can be included. Let's see if that's for service or repair, including fastening. So it can be easily included. For the third model, it depends on the component and also the availability of the degradation model available for the component. These can also be easily included. Here, we only consider rail sleeper as ballasted for conventional ballasted track. But this, we also propose method to allow, let's say, slab track to be modeled as well for this model. For the first and second, yes. So all of 3 can include the cost elements from, I would say, all major track components.
Thank you.
Perfect. We'll give it a second to see if there's any other questions. All right, doesn't seem so. So thank you so much, Wenxi, for that presentation.
Thank you.